Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 8, Neet Physics 2014. Students, let us solve the next question, which is talking about the oscillation of a body on a smooth horizontal surface. The body is oscillating on a smooth horizontal surface. Suppose this is the body which is oscillating. This is the mean position and oscillating about two extreme points. It's moving to and fro in between these two extreme points. And it is given by the equation, this displacement is given by the equation x is given, x is the displacement at time t, at any time t or at time t equals to 0. That has to be mentioned. X is a function of time, x equals to a cos of omega t. If I say that this is the displacement at any time t, but then it is obvious that here if I put t equals to 0, then x becomes a. So that is the initial phase of the oscillation. The oscillation starts at a. If I put t equals to 0, then x becomes a because cos 0 is 1. That means the oscillation is actually starting from this position towards this at time t equals to 0. So that alpha value is 0. Alpha is called the initial phase. If I go for the general expression of x, that is a sine omega t plus alpha, when this at this point starts moving, alpha is 90 and sine 90 plus theta is cos theta. So that is the correct representation. With angular frequency omega is the angular frequency, which one of the following graphs shows correctly the variation of a with t? A stands for acceleration and t stands for time. So we have to find the or draw the acceleration time graph. Okay, I'll draw all the graphs for you. First of all, there is a trick to solve this. The trick is that if I know xt graph, here the xt graph is a cosine function starting from a plus a and a minus a. So it varies like that. It goes like this. Plus a and minus a. If I know xt graph, this is for x and t graph. With time, this oscillates like that. Displacement is 0, a at xt equals to 0. This is xt graph. Now we know that if I differentiate this, keep on differentiating this, then x is a cos omega t. If I differentiate this, then v equals to a omega minus, this becomes minus sine omega t. Okay. If I further differentiate this equation, we'll get acceleration. So displacement derivative gives you velocity, velocity derivative gives you acceleration. This acceleration will be minus a omega square cos of omega t. What is the basic difference between these two curves is that this curve is inverted. You could see directly is inverted because this is plus and this is minus. Another difference is that the amplitude here is a and here the amplitude is a omega square. The nature of the curve will remain inverted, but amplitude there will be variations. But we are not interested in that amplitudes because we want the variations. Basically, if you see the graph, then if I plot the graph myself, then it will look like this. This is for plus a, minus a. This is for xt curve. If I, the shortcut method is that if I go, this is 90 degree apart, this is 90, this is 90, this is 90, this is 90. So this is whole thing is 2 pi. So shift by 90. If I bring this axis over here, then that gives me VT curve. If I further bring it by 90 ahead, like this curve gives me AT curve. That means AT curve starts from here, down below. Otherwise, you can see that this is cos omega t, this is minus cos omega t. Forget about these two terms. Obviously, the amplitude will be different than this A, but the nature of the curve will be here, that starts from the lower extreme. AT graph will start from the lower extreme, and as shown in the figure or otherwise also. So, starting from lower extreme is this one. This is the graph which is starting from lower extreme. This is starting from upper extreme, so this is not correct. Starting from origin, not correct. Starting from here, not correct. So this is the correct answer. Let's start from here. So the nature of the curve for this should be from here. The graph is like that. This should be the graph starting from here. Okay. Otherwise, you know cos. Invert it means this will come down to this place. This will go down to that place. So it will be like that only. Just invert it. Okay. So the answer to this question is question number 8 is option number 3. Okay. Thank you.